Okay, so if we're going to try and graph some harder absolute values, if you look at something like number 10, you know how to do this. It's the same thing like we did yesterday. No surprises, nothing's different. Because if you recall yesterday, we wrote down this formula. Y equals A times X minus H plus K. Right? So we have this equation. This fits that. I have H comma K. That's where my vertex is. A just tells me about the slope. Everything's fine. So number 10 is really not that hard to graph. I already know what the parent function looks like, so I would just start it at -1, 2, and then I follow this, tells me where to go, and since it's a -3, instead of going, oh, did we do anywhere it was different? Oh, we didn't. Okay. Maybe I'm speaking too soon. Maybe we don't know how to do this past this point. But you kind of do, because it's sort of the same thing as what we do for the quadratics. So right here, right, I have my vertex, -1, 2. Same as normal. But now this isn't just 1 or -1 anymore. It's -3. So because it's negative, what do you think that's going to do to the graph? Flip it upside down, right? So now I'm going to have an upside down V. Okay, that part's easy enough. So then what do you think's going to happen because it's a 3? What happened to the quadratic when we changed the number? Didn't it get more narrow? It was a more narrow U shape? Or a more wide U shape if it's a fraction? So same thing's going to happen here. It's just going to be a more narrow V. So on your absolute values, you normally just go up 1 over 1, up 1 over 1. That's it. Here, I'm just going to do -3 instead. So it's kind of like telling me my slope from the first point. So -3, I'm going to go down 1, 2, 3 over 1. And these are just straight lines, so I just can keep going down 3 over 1. I'm out of room here, but don't forget to do the other side of the V, so I also have to go down 3 to the left 1, right? Just mirroring it over, and that's how I get this V shape. Ah. So it's everything I thought it would be. It's a narrow V shape, it's upside down, and it has the vertex at -1, 2, just like I thought it would. Gosh, they're all negatives. I don't know how that happened. Let's do number 12, but I actually want you to change it to a +2. So cross out that negative, please. All right, go ahead. Try and graph number 12. Start with the vertex, and then you just follow whatever A tells you to do. You think you got it? So, where's my vertex? 2, 2, you bet. And now, all I have to do is look to A to tell me my next step. Since we changed it to a +2, it's like my slope, so I'm just going to go up 2 over 1. And then I do the same thing to get the left-hand side, right? I just go back 1 instead. I can go up 2 over another, and that should be your shape. Is that so bad? Yep.
So for 11, without the negative, it would be up 3 over 1.
Yeah, if it was a +3, you go up 3 over 1. Whatever it is, it's basically telling you your slope of the right-hand side.
Wait, wait, why is it going up?
Because I told you to cross out the negative.
Oh.
But you're right. If that negative was there, it'd be down. It was just that every single one on this page is negative, so figured we should practice a positive one. All right, so go ahead and try 11 if you haven't done it yet. Leave it as it is. Where does my vertex go? You bet. -4, -3. And then, because A is -3, where do I go from here? You got it. Down 3/1, and I'll just mirror it on the other side. Sharp V. Done. Alright, unfortunately, they don't stay this easy. Because if you look back up at number 9, this doesn't fit the form anymore. Look at my form. I had a number on the outside, and then just x minus h plus k. Here, I have -3x minus 3. It's not just an x by itself and then plus minus some number. So this doesn't fit this. So I don't just know where my vertex is. I don't know how wide, narrow, what's going to happen with it. Basically, the only thing that I know for sure is that it will be a V shape because it's an absolute value, and so they're all V's, and it will be upside down because I've got this negative out in front. Beyond that, I really don't know anything. Shoot, so what are we going to do? Well, lucky for us, there's a way to manipulate this equation so that it does look just like this. Ready to see how? You might need I'm going to write this in this notebook. I need a little bit of room. There we go. Okay. So let me just copy the equation on here. So y equals negative, absolute value, -3x minus 3 plus 2. All right, so if your equation is not in this general form, here's what we can do. I kind of want to force this coefficient to be a 1. So what I can do is I can factor this. Check this out. I'm going to take a -3 out of here. If I pull a -3 out, what would be left? What would go inside this? Plus 1, right? Right? And if you distribute that back in, wouldn't that just get me right back to the -3x minus 3? So I just factored out a -3. Now, it still doesn't look like my form, but I'm almost there. I'm going to use this really cool thing, this property of absolute values. Watch this. Well, so let me just do a little side note. You don't have to write this down if you don't want to, but say I took the absolute value of -2 times 5. So if I asked you to evaluate this, what is your answer? 10, right? Comes out to be positive 10. -2 times 5 is -10, but the absolute value is positive 10. Okay? So what's cool about absolute values, if I have multiplication, I can actually split them up and get the same answer. So in other words, the absolute value of -2 times the absolute value of 5 is going to be the same thing. Don't I still get 10 if I do that? So it doesn't matter. They both end up equaling a positive 10. So I'm allowed to sort of split them apart and then take the absolute value separately. So that's exactly what I'm going to do here. Let's see if I can get it all at the same time. See how I now have multiplication in here? I have a -3 and then times this whole thing. So watch this. I'm going to split it up like this. I'll take the absolute value of -3 times the absolute value of x plus 1 plus 2. Does everybody see what I did? So this negative just kept coming down, so that didn't change. I factored out the -3 from the inside. Everything is still inside one set of absolute value bars. But now that I have multiplication, I can now do the absolute value of -3 by itself and the absolute value of x plus 1 by itself. And then I just bring down that plus 2. And then we're almost there. I know what the absolute value of negative 3 is. It's just 3. So when I evaluate this, I do still have that negative out in front. So now I just have negative 3, absolute value of x plus 1 plus 2. And now it is in the form that I wanted. So I do know what the vertex is, and I do know how to graph all the other parts. I just have to do this weird factoring step first in order to get there. But now, hopefully you can see, all right, my vertex would be at negative 1 comma 2.
So you go backwards.
See if I can get it all at once. So negative 1, 2 would be here, and then I just follow my slope. So I'll go down 3 over 1. And, oh, excuse me, all done. So it's easy once I get it in the right form, but there's no way, looking at this original, you wouldn't have known that your vertex is going to be negative 1 comma 2, right? It doesn't, so if you tried to do it, someone's going to think that the vertex would be at 3 comma 2, and they would be incorrect. It is not at 3 comma 2 at all. So if your absolute value is not in the right form, you just got to force it to be in that form. Yep. So it is, for a second, the absolute value of negative 3 is 3, but since there's that negative out there. All right, let's try another one like this. I think if we flip this paper over. Okay, let's try 14 as another one like this. So 14, let's recopy it here because I need more space. Negative 2, absolute value, negative 3x plus 4. Oh, this is a really good one. Okay, so it's not in the right form. I have to make this, it has to be just a 1 there. So I basically have to factor out a negative 3. This time, it's trickier though, because it doesn't factor so nicely, right? In the last one, it was easy. I just took a negative 3 out of both, no big deal. But this time, I still have to do it. I don't have a choice. It's just that I'm going to end up with a fraction. So what do you think you get, guys? If you take out a negative 3, what would be left in there? What's the first thing? X, obviously, right? Okay. And then what would go here? What would you multiply by negative 3 in order to pop out a positive 4? Once you see it, you'll see that it's actually easy to get that number. Let's talk about the sign. What sign would it have to be? A negative times what would get me a positive? So this has to be a negative something. Just don't know what yet. You're close. 4/3, yes. Guys, all you're really doing is taking whatever that coefficient is, and you're just dividing each one of these things by it. Right? You just take the negative 3 and divide it by 4, and that gets you your number over here. Same thing you did it up here. You just didn't even realize that you were. Negative 3, if I just divide it into negative 3 divided by negative 3 gets me a positive 1. So when they're not nice like this, it's helpful to remember that. I'm just dividing both of these terms by whatever that is. So I divide this by a negative 3, so it just turns into a 1. Divide this by a negative 3, and that's how I got the negative 4/3. Hopefully that's helpful. And then I'll just bring down the minus 3. So now I can do that thing where I split these up. So I still have this negative 2 that's just coming down, But now my absolute value is going to split into two absolute values. So I'll have the absolute value of negative 3, and then the absolute value of the x minus 4/3. And then minus 3 on the end. And now we're almost there. I know I can do this. The absolute value of negative 3 is 3 times negative 2 is just... You got it. So now this is the form that I want. It's just a fraction. Oh well, sometimes that happens. So now I know my vertex would be at 4/3 comma negative 3. And then I can follow my slope from there. Oh, that's going to be quite narrow, isn't it?
I don't think it's just off the top.
Let's see. So 4/3 is 1 1/3. What number is this? 14? Yeah. So 1 1/3. Oh, excuse me. I don't know why I'm so tired today. Yeah, you're right. Negative 6, I'm already off the graph. Oh, I'll just approximate. 1, 2, 3, 4, 5, 6 over 1. Okay, you try 15. Luckily, 15 is one where it kind of works out nicely. So 15 should not have any crazy fractions in it. Did we get a graph? All right, let's try it. So I have to force factor out a 2, but lucky for me, 2 factors pretty easily out of that. And in here I would just have x what? Thank you. All right, so now I'm there. Now I'm ready to split my absolute value into 2 parts. So I'd have negative 3, absolute value of 2, times the absolute value of x minus 1. All right, I know the absolute value of 2 is just 2 times negative 3 gets me a negative 6, x minus 1 minus 4. And now I'm ready to graph it. It's nice and easy. You should have a vertex at positive 1, negative 4. And then my negative 6 again, geez. One more, and then we'll move on. Try 16. You'll have to force this one because they don't divide evenly. Okay, so when I factor out that -3, what's left in there? Yes, perfect. X plus 4/3. I still have that -3. Split them up. Okay, and then we're almost there. Absolute value -3 is 3 times -3. Ooh, -9. That is steep. Okay, so this is definitely not going to fit on our graph, but we can at least get the vertex down. So your vertex should be at -4/3, comma, -3. So that would be -4/3 is -1 1/3, -3. 1, 2, 3. And then down 9/1. So that'd be awfully narrow. What do you think? Not so bad? A little bit bad, but doable?